Hello. Now we will see client-side load balancing, and we can also call Spring Cloud load balancer. In a distributed environment, services need to communicate with each other. Communication can happen either synchronous or asynchronous. Whenever service is communicating by synchronous, then it is recommended to use load balancing. There are two ways to load balance. One is a server side load balancer and second one is a client side load balancer. Server side load balancer means whenever incoming requests are received and those are distributed among services. And whenever client side load balance is used, then whenever number of requests are sending from client to server, client side itself will load balance. And what is the purpose? Means if we are using client side load balancer, we can reduce maintenance cost. Then what are the client side load balancers available in the market? That is like Spring Cloud load balancer, Netflix ribbon. Initially Netflix ribbon was used, but they stopped updating libraries and all. Then people are using latest one is a Spring Cloud load balancer. So obviously latest one we need to use. Then what are the required dependencies we need to use for achieving Spring Cloud load balancer? We need to write load balancer dependency org.spring.springframework.cloud and artifact ID would be Spring Cloud Starter Load Balancer. From where we are going to download means you can visit start.spring.io and here you can type add dependencies Spring Cloud routing. Then you can easily get this dependency. Once we get this dependency, we need to add it in pom.xml. And see, if we go inside the architecture, there is a client, we can say client. In earlier session, we have seen Fein example. Now also I am taking Fein example as the client. This is a client and server side there is a student details 8090 port. And we can see this one. And we can see server side there is a student details that is running on 8090 port number. So whenever client is sending, all the client are reaching to student details. Suppose let us say thousands requests are receiving to student details. Then what will happen? A server instance performance would be reduced and performance will be degraded. So if more requests are receiving to server instance, then definitely server instance performance will be degraded. To overcome this, if load is distributed among many server instances, then application performance will be too good. That can be easily achieved by cloud load balancer. Like here, if you see, client is sending two requests to 8090, the same request, student details, and two requests are sending to 8092 port. That means same service only, but server instances are two server instances. If one server instance is there, then load will be more. If more instances are there, then load can be easily distributed among server instances. So here if 4 requests are there, equally distributed. If 10 are there, 8090 port number will take 5 requests and 8092 will take as 5 requests. But who is consolidating this request? Who is maintaining this request? Who is sending? Who is organizing this request? 5 requests should go to 8090 port and 5 requests should go to 8092. And imagine if 10 requests are there, equally distributed among server instances. Not only 2 server instances whatsoever. If 4 are there, 4 servers will take the equal request. If 10 are there, 10. Here what we need to understand is if 1000 requests are going to the server, 1000 will be distributed among the available server instances. Then who is taking that responsibility means a client side load balancer. That is Spring Cloud load balancer will take the responsibility. We'll see the architecture. As earlier we have seen microservice 1, 2, 3 and Eureka server integrated, API gateway also integrated and client also, Fain client we have integrated. And if you can see here, client is requesting through Fain. So before Fain we need to add one more dependency we need to add, that is a load balancer. This is a horizontal structure. If you see vertical, then client application, it can be client can be through from the internet or whatsoever, and client application will send the request through Spring Cloud Load Balancer. That request will reach to Fain client, and Fain client will go through API gateway, and API gateway will go through Eureka. Before reaching Spring Cloud Load Balancer itself will organize the request number of requests, and it would be equally distributing to the available server instances. That is the main thing we need to understand here. So this is about Spring Cloud Load Balancer. In our next session, we will see how practically we can achieve Spring Cloud Load Balancer and how equally distributed load to available server instances. Till then, thank you.